So class, today we will study about the factors affecting the rate of reaction. In previous class we have done the rate of reaction, how we will find the rate of reaction, instantaneous and average rate of reaction. So now we will know that what are the factors which affect the rate of reaction. And you know, this is the very important part of this chapter, and almost maximum more than half of this chapter will be covered in this topic only. Okay, so the first thing, that is concentration of reactants. Second thing is nature of reactant. Third is temperature, and fourth is catalyst. So these are the four factors which can affect the rate of reaction that we have to study. Other than this also lots of factors are there, but we have to learn only in these four. Okay, so out of these four, let me start with the first one, that is I have written concentration of reactant. So I just want to ask that it's very common thing. Yes, if we have lots of concentration of lots of reactant, then obviously the rate of reaction will be faster. So you can relate it with a common example, with day-to-day life example. Okay, so why this happens, like why the rate of reaction is depending upon the reactants. So see, actually there is a theory, that is kinetic theory of gases, or you can say have done the collision theory. That collision theory is in the last of this chapter, although that part is deleted from our NCERT syllabus this year, but we will do. So I'm going to explain the basic thing, what is in the collision theory. So in the collision theory, it says that number of reactant particles, they collide with each other, and each perfect collision gives a result in the product formation. So if more number of reactant will be there, more collision will be there, and hence more product will form. That means rate of reaction will be fast. Yes, rate of reaction क्या है? Reactant से product के बनने की tendency. So this is, if more number of reactant will be there, more collision will be there, and more collision, that means more product formation, and hence the rate of reaction will increase. So we can write it that rate of reaction is directly proportional to the concentration of reactant. Okay, there is no dependence on the product concentration. It simply depends on the reactant concentration. Okay, reactant. So rate of reaction is directly proportional to reactant concentration. This is experimental theory, experimental value, experimental thing. So in this, the scientists, by the experiment and all, they said that rate is not exactly directly proportional to reactant. Actually, the rate is directly proportional to the reactant concentration to the power n. Okay, and this n will explain, don't worry about that. Okay, so this is R is directly proportional to reactant to the power n. And what they said, this n is equal to, what is this power? This n is order of reaction. Okay, order of reaction. So let's do this. If we know that if we remove the proportionality sign, what we do? We put a constant. R is equal to K, concentration of reactant, isn't it? And let me give the power n. This n can be any whole number, any number, 1, 2, fraction, even negative भी हो सकता है, कुछ भी हो सकता है. Okay, don't worry. So this is like, there is an example. If I am taking example, A plus B change into C plus D. 1 second, I think I have said negative also. It's not negative. It can be 0, it can be 1, or it can be fraction. Okay, not negative. It can be 0, any fraction, or any number, Okay. Okay, so now this is like, suppose that this is the reaction. We don't have to consider this product. कोई रोल नहीं होता इसमें, ठीक है. So we can write this rate of reaction is equal we can say directly proportional. Okay, concentration of A into concentration of B. Can we write like this? Yes. And here we will this power n, let it be. Suppose that this is n and this is m. Okay, and it can be like whatever the unit will be there. I will tell you what. Just don't worry about this. So this can be whenever we remove the proportionality sign, we put a constant, and here it is k, a power n and b power m. Yes, so this expression is known as rate law expression. Rate law expression. Clear? Any problem in this? Okay. And in this, what we have to see, in any rate law expression, the sum of the power of the reactants is equal to order of the reaction. Okay? In any rate law expression, this is very important thing you have to keep in your mind. Rate law expression, the order will be this. I have explained now, n is equal to order. So this order will be equal to sum of power of reactants concentration. Reactants concentration. Got it? Clear? So this is the important thing. So for this equation, what is the order? Order will be equal to m plus n. Isn't it? Okay. Few things I want to explain about it. The order of reaction. First thing I have told you that order of reaction, whatever this we find, order of reaction, it is an experimental value. Experimental value. We cannot find this order of reaction theoretically by saying any balanced equation. We cannot say. Okay, we cannot tell. Second thing, it is not related with the stoichiometric coefficient. It is not related with the stoichiometric coefficient. Not related with stoichiometric coefficient. Okay. Third thing I have told you, it can be 0, fraction, or any number, any whole number you can write. Okay. And third thing, not related with the product concentration. Not related with the product concentration. Got it? See, in many I just let me explain it with an example. Suppose that if I'm giving you example AA plus BB CC plus DD, and suppose that this example I have given, and then I said write rate law expression, write rate law expression for this, and find the order, So see, in this question, it is not given, the rate law expression is not given. So we will go according to the balanced equation, and the rate law expression will be R is equal to K, concentration of A reactant, and the stoichiometric coefficient will be converted into this power. Since it is not mentioned, rate law expression is not mentioned, so we can go theoretically. Is it okay? And then B, and it will be B. It is not a proper plus sign or multiplication sign. So this is the rate law expression, and what will be the order? According to this, since we got the rate law expression this, okay, so according to this, order of reaction will be A plus B. Done. But if the question like this, for the reaction AA plus BB change into CC plus DD, the rate law expression is given. Rate law expression is given like R is equal to K A power A and B power B by 2. Suppose that it is given. So now we don't have to check what is the balanced equation. If rate law expression is given, we don't have to check the balanced equation. Got it? समझ में आएगा? So in this case, we just have to check the rate law expression, and here order will be A plus B by 2, which is not exactly equal to the stoichiometric coefficient. So got it what I said? There are two type of question. In the first question, suppose that if rate law expression is not given and the question is asked that find the rate of reaction with this equation according to this equation, and rate law expression is not given, so we will do it like this. But if rate law expression is given for any equation, then we don't have to check the balanced equation. Got it? We will say according to the rate law expression. Another example also we can do. See, another example, suppose that I am taking 2NH3 change into N2 plus 3H2, and for this rate law expression is given. Rate law expression is given R is equal to K NH3 power 0. This is the given thing. This is experimentally given. Okay, got it? So what will be the order here? Order will be 0. We don't have to check this balanced equation. हमें नहीं देखना होगा. If rate law expression is given, we will not check the balanced equation. Got it what I said? Any problem in this? Okay. So this is the equation. This is called rate law expression. As for example, another one, if example question is given like for a reaction 2NO plus O2, this is gas and this is also gas, change into 2NO2 gas, and the rate law expression is given for this is given R is equal to K NO power 2 and O2, like this. So here by chance the rate law expression, in the rate law expression the power of the reactants and the stoichiometric of the reactant in a balanced equation are same. This is by chance. Got it? So anyhow, we don't have to check the balanced equation. If rate law expression is given, we don't have to check this. So according to rate law expression, we can say that the order of reaction is 2 plus 1, 3. Got it? So like this we can find. In this, few questions can be asked. So for this, suppose that another example also, you can take so many examples are there in your NCERT, you can follow. Okay. So like another example is given for CHCl3 plus Cl2, and that is going to convert into CCl4 plus half Cl2. Sorry, HCl. Okay, this is. So, and for this, the rate law expression is given. Let me write only rate law expression is given K. This is and Cl2 power half. Although in the stoichiometric coefficient it is 1, but since rate law expression mein it is given half, so we have to check the rate law expression only, and the order of reaction will be what? 1 plus 1 by 2, that means it is 3 by 2. Got it? So this can be the equation. Another example, or like we have done the hydrolysis of sucrose. We can do that hydrolysis of ester also. Okay. So let me write the example. This is CH3 COOC2H5. If it undergoes hydrolysis, it gives, you all know this, ester on hydrolysis it gives alcohol and acid CH3COOH plus C2H5OH. And according to equation, if we check, the stoichiometric coefficient is 1 and 1, it should be 2, order should be 2. But if we check the rate of rate law expression, the rate law expression is R is equal to K and CH3COOC2H5 and H2O power 0. This is the rate law expression. So what will be order? Order will be 1 plus 0. This is 1 and 0. 1 only. So with all this example, what we got, that order of reaction depends in according to rate law expression. Order of reaction depends on rate law expression. What is the rate law expression? In that, whatever the power of the reactants are given, we have to make the sum for that only. Got it? So I hope it is clear. Chaliye, now let's do with the unit of rate constant. Achha, one thing I have not explained, just wait, and that is K. Here we have used the constant in the rate law expression. We have done this K constant, and this K is known as rate constant. Okay, so now unit of rate constant, it depends upon the order of reaction. It depends upon order of reaction, or in other way you can say that it order of reaction, K unit can give the order of reaction. Got it? Order of reaction. With the help of K you can find the order of reaction, or with the help of order of reaction you can find K. Vice versa it can be. As for example, like start with the zero order. R is equal to K and zero order. What I have to make it? 0. Yes, and we know that anything power 0 is equal to 1. So can we write R is equal to K simply? So whatever the unit for R, that will be unit for K, and R unit we know that mole per liter per second. So if K unit we are getting mole per liter per second, it is zero order reaction. Let me give the heading zero order reaction. Okay, another, if for first order reaction, what we'll write? R is equal to K a power 1, let it be. Yes, so K will be equal to R upon A, isn't it? And R unit we know that क्या होता है? Mole per liter per second, and concentration unit is mole per liter, isn't it? So cancelled, and you will get the unit of K second inverse. Any problem? Similarly, you can find for the second order, and maximum order of reaction is third order. More than that, it's not possible. If it is coming like that, that means the reaction is occurring in the several step. Okay, even for the second order also, we cannot say that it is a single order reaction or single step reaction. I will tell you that also, just wait. Second order reaction. So for the second order reaction, can we write like this? A power 2, maybe of two different component bhi ho sakte, two different reactant bhi ho sakte, but anyhow we have to write the unit of concentration. So either it is A or it is B, it will be the same, isn't it? So K will be here R upon A power square, isn't it? R is equal to, we know that, what is that? Mole per liter per second, and concentration unit square, mole per liter per second. This will be mole cancel, and so mole in square, left will be mole inverse, and then liter will come out like liter, and this is per second. So we can write like this, isn't it? Liter per mole per second. So there is a general formula for order of reaction also. We can find the order of reaction with the help of order, and that formula is mole per liter 1 minus n per second. This n is equal to order of reaction. So you can find easily. Yes. If order of reaction is 1 minus 1, it will be 0. So whole power is what? 1 and per second. So first order it will be per second. For zero order, 1 minus 0. So mole per liter per second. Yes, like this we will get. Got it? See class. So order of reaction, how it can be explained, how it can be defined. So for defining this order of reaction, this is the sum of the powers of the concentration of reactants in the given rate law expression. This is must point. Okay, is called order of reaction. Clear? So this is quite clear. That should be rate law expression. Okay. A stoichiometric coefficient, there is no dependence on the stoichiometric coefficient because it is an experimental value. Now, any reaction, actually whatever we see that A change into B, A R change into P, it seems that the reaction is occurring in the single step, but maximum like 98% reactions, they take place in several steps. And reaction taking place in one step, such reaction which take place in one step, they are called elementary reaction. Okay, but if it takes more than 2 or 3 steps, then it is called complex reaction. When any reaction completes in sequence of steps, and that sequence of step is known as mechanism. Okay, so we have done in class in organic, yes. Then this is called complex reaction. And out of all this sequence of reaction, the equation, the reaction which is slowest, the step which is slowest, that is called rate determining step. And actually वहीं से order हम निकाल सकते हैं. Got it? What I said. Out of all the step, the slowest or the slowest step reaction is known as rate determining step, by which we can find order of reaction, which give order of reaction. Okay, so for this I have written a question, so let us do with this question. Okay, so this is 2NO plus Br to change into 2NOBr can be written like this. So if I will ask, write the rate law expression. So in this, write the rate law expression. Rate law expression. So see what to do. As I told you that it is slow step. So which one is slow step? This one. That means according to this we will write the rate law expression. So if we are writing this, R is equal, then the rate law expression can be written like this. R is equal to K NOBr2 and NO. Isn't it? That will be the rate law expression according to this concept, the slowest step. But one more thing you have to keep in mind. If you are writing this rate law expression, in that rate law expression, the reactant must be there. Are you getting it? Whenever you write the rate law expression, in that case, the reactants must be there. That means you have NO and Br2, but when you are writing the expression, Br2 is not there. You are getting another one, isn't it? So for replacing this NO Br2, we have to take the help with this equation. So for the equation 1, okay, can we write that? One more thing I just want to explain it here. In this way, if it is going, this is the forward reaction. Yes, as we have done in equilibrium, and this we have done in backward reaction. Okay, so Kf upon Kb, we know that, and that is equal to K, isn't it? So can we write that K is equal to product upon reactant concentration? Just remind class 11th equilibrium part for this. Can you remind it? Kf is equal to क्या होगा? For Kf, this is the concentration, this is the reactant, isn't it? And for backward, this is the reactant, and Kf upon Kb करोगे, you will get this, isn't it? So like this. So if we have to assume कर लो, this is K1. Okay, so to get this NOBr concentration, what we have to do, we will take K1 into NO2 power and Br2. So in this case, we are getting this reactant NO and Br, which is in the main reaction, isn't it? So now instead of this NOBr2, you put the value of this. So it will be K into this, K will be remain like this, and instead of this NOBr2, you have to put this one. So this is K1, and it is NO. What we say? 1 second, some mistake is there, I think. I have done, yes, this should be NO, no, only, yes, this is not like that, so that's why it won't be like this, it won't be like this, yes. Okay, so now this NO in Br2, yes, and then this is NO. So what we are getting, this 2 is constant. Instead of these two constant, I can put a constant on new, and that is, suppose that k dash I am putting. Okay, so this will be NO square and Br2. So what is the order of reaction? Same, 2 plus 1. But this k, k dash is equal to k into k1. That is the thing over here. Clear? So and if I will say to write one thing, let me measure this. This is k. For this reaction it is k1, and for this reaction it is k2. So this is k1 and k2 if you are assuming. So it should be k2, isn't it? This is k2 because this is the rate constant over here, and now this is k2 into k1, that is k dash. Okay, got it? So this is the rate law expression for this equation. Got it? I hope it is clear. And the order of reaction, if you'll find, order of reaction is 2 plus 1. So what you have to see, if you will find this order of reaction according to this equation, that will also be same. But what is the change? What is the difference over here? This is not K1, neither K1 nor K2. It is something different rate constant, which is equal to K1 and K2. Are you getting it? So this is the only difference here in this case. Similarly, too many questions are there. I will give you one more questions for practice. We have another equation also. So this is for you. You have to do this. Suppose that this is another example, and the question is like the reaction to H2O2 shouldn't write this. H2O2 change into, in presence of I, alkaline medium. Okay, alkaline medium. This is going to convert into 2H2O plus O2. So write the rate law expression. If this equation can be written like two equations is given, like H2O2 is going to first react with this I minus to give H2O plus IO minus, and second one is H2O2 plus IO minus is H2O plus I minus plus O2. Okay, so in this case you have to according to this equation you have to write the rate law expression for this, and this one is fast and this one is slow. Okay, so write the rate law expression for this. Expression, suppose this is K1 and this is K2. So you have to find the rate law expression for this equation as we have done. This is the homework for you. Okay, so I think it is clear. Any doubt you can ask. Thank you, class.